It's just algebra. So that means, unfortunately, I have the largest set of options. I'm going to check for a U substitution first. So my most straightforward U substitution would be to pick part of this and think about that as being U. Well, if x cubed were equal to U, then du would be 3x squared, which I don't really have, because even though I have an x squared in the denominator, that du would then have to be like a something over x squared dx. And that's not what our derivative of x cubed looks like. So the other thought would be, well, maybe it's the x squared plus 1 that could be my u. And if u was equal to x squared plus 1, then I'd have the derivative being 2x, which I kind of don't have in the top because I have an x cubed. So my next thought, moving on from u substitution, would be to check the powers. Well, my largest power of x, if I multiplied this out, would be x to the 8th in the denominator. So it's not long division, which would lead us to partial fractions. But I hope that we're all going to look at that and say, as a partial fractions problem, it is absolutely terrible. So if you happen to be taking notes, stop writing for a second, because we are not going to do it this way. If this were going to be a partial fractions problem and I had that irreducible quadratic raised to the 4th power, then I would have to have x squared plus 1 to the 4th with a linear term on top, plus x squared plus 1 to the 3rd with another linear term on top, plus x squared plus 1 squared with another linear term on top, and then an x squared plus 1 with, yes, another linear term on top. There is no way that this is how we're supposed to do the problem. There must be something else. And when I find myself going, there must be another way, usually there was a u substitution that at least would help as an intermediate step. So I'm going to go back to this and say, well, if I had to pick something to be u, I'm probably going to pick the piece that's sort of the messiest, which is that x squared plus 1 raised to the 4th power. And if I were to let u be equal to x squared plus 1, then du is 2x dx. And when I did this before, I said, I don't have that in the numerator. But if I'm clever, I can think about that x cubed as x times x squared. The reason that that's helpful now is the x dx I have, and if I think about this u substitution as my vocabulary list, it's pretty easy to get x squared from my vocabulary list. If u is equal to x squared plus 1, then that means u minus 1 is x squared. And I can replace everything in this problem with something in terms of u's. My x dx would be 1/2 du. So I'll have a 1/2 out in front here. And the x dx will turn into du. My denominator becomes u to the 4th. And that x squared, I can rewrite as u minus 1. This is much friendlier to work with. Now that I have a single term in my denominator, I can break that apart into 2 pieces and have 1/2 of u over u to the 4th minus 1 over u to the 4th. Or, rewriting it yet again, u over u to the 4th becomes u to the negative 3rd, and 1 over u to the 4th becomes u to the negative 4th. And each of those follows my general power rule. I'm going to add 1 to the exponent. I don't know what happened to that parenthesis. That's what I get for not looking at the board. Okay. Add 1 to the exponent, I'll be at u to the -2. Divide by that -2. Add 1 to the exponent here, I'm at u to the -3. Divide by that -3, plus a constant. And then don't get all this way and forget to plug your x's back in, because we want to make sure that we get all our points. So that 1/2 times -2, I'd have 1 over -4 u squared, but our u is x squared plus 1. The 1/2 times the 1 over -3 would give me -1 over 6 x squared plus 1 to the 3rd. So we have just a couple of minutes left. I don't know if there's one last problem that anybody would like to see me go over, or any last questions that you might have.